So it is recorded. Are there any questions? Which is recorded. Any questions? I'm not sure, double check. Okay, should be recorded, yeah. All right. So before break, we did Unit 5 about descriptive statistics. Now we move on, Unit 7. Unit 6, t-test procedure, okay? So just going back. So there are 3 lessons. Lesson 5, this is a Unit 6, should be Unit 6, t-test. Lesson 22, one sample t-test. Lesson 23, paired sample t-test. Lesson 24, independent sample t-test. For each lesson, I will go over example from the textbook, and I will explain the output from SPSS. Okay, so first we go one sample t-test. For this one sample t-test, we usually assume the test variable is normally distributed. And we also assume the variables are random variables. There is an important concept called effect size statistics. Effect size statistics. It is just test statistics t divided by square root of sample size. Different test has a different formula for effect size statistics. For one sample t-test, test statistic t divided by square root of sample size, that is effect size statistics. Okay. So now we are going to open a data file 2022. Okay. So where's my statistic? So this is 21. I will not save it. I will save. Change the data. No. Just close it. So I quit the SPSS. So open data file, lesson 22. So in this data file, we have 30 participants, 30 students. The variable KUDI it is go to variable view. It is a KUDI depression scale. KUDI depression scale. And how this variable is defined. So if you go to the description of this variable. So KUDI, it is a represent depression score. Based on previous research, we know young male adolescents have a mean of 50 on KUDI. So 50 is the test value. We choose 50 as a test value because based on the past study. Okay. This is just one sample. So we are going to do one sample t-test. To test what? To test if the mean, we want to test if those mean is equal to 50 or not. Where the test value 50 coming from? It is coming from the past research. In the past, the research shows the average is 50. So we want to test if the average for this data is 50 or not. Okay. So to do that, we do analyze, compare means, one sample t-test. We just have one variable, KUDI, and now test value, type in 50. We want to test if the population mean is 50 or not. That's it. Then you click OK button. You will get test result. And now, where is the test statistic? So this value is test. I'm going to copy the screen so that I can make annotation. So this is lesson 22. T-test. Maybe I will go here. Just keep on going. So this is our test result. Our test statistic is 2.457. And if it is a one-tailed test, the p-value is 0.01. If it is two-tailed test, the p-value is 0.02. In both situations, we have a p-value we usually compare p-value with alpha. The popular alpha is 0.05. We use alpha 0.05. And our p-value smaller than p-value is smaller than alpha. When p-value is smaller than alpha, you reject H0. So what is our H0? H0 said population mean equal to 50. Alternative hypothesis said population mean not equal to 50. Okay, since our p-value smaller than alpha, we reject H0. Therefore, we conclude the population mean is not 50. Okay, so based on the sample data, we draw conclusion about population. We conclude at 0.05 level of significance, the population mean is not 50. Any questions? So this is a p-value method. And if you want to use a test statistic, you compare test statistic with critical value. Okay, critical value. And then you have to find out critical value. Okay, so how do you find out critical value? You can use use Excel. Remember, first week we reviewed the critical value. So for this question, how do I find the critical value? I'm going to show you in Excel. Oops, why I have that? No. Try to open my Excel. So in Excel, you type in t.inv.2t, two-tailed test. Probability is alpha 0.05, degree of freedom 29, because we have 30 participants. Degree of freedom equal to sample size minus 1. And you get a critical value 2.045. Okay. So critical value, use Excel, you use t.inv.2t. Probability 0.05, degree of freedom 2.045. This is critical value. And then you compare critical value with the test statistic. Test statistic is, so maybe label critical value first, 2.045. Critical value decide rejection region. Because of symmetry, there is another critical value, negative 2.045. Those are the rejection region. Now label your test statistic 2.457 must be here. That is 2.457. Obviously, test statistic is in the rejection region, so you reject H0. Same conclusion as we get from p-value method. You reject H0 in favor of H1. Okay. Any questions? That is a one sample t-test. One sample t-test. Any questions? Let's check. Okay, I don't have any questions here. Okay. So now let's move on. Lesson 23, paired samples t-test. Paired samples t-test. I'm going to open data file, lesson 23. So this data, you have two variables. One is the pay, the other is the security. So if you go to variable, what is the pay? It is a concern for pay. The higher scores indicate greater concern for salary level. And the next one is security. It is a higher score indicate greater concern for job security. For job security. All right. So what is the research question here? So you have those data. What is research question here? Let's go to lesson 23. So we get the data, two variables. The assumption for paired sample t-test is the difference are normally distributed. Remember, when you have paired samples, the very first step when you do manual calculation, you do the difference of those pairs. So assumption 1, the difference are normally distributed. Okay. Assumption 2, samples are the case represent a random sample. For the effect size statistics, and this is the formula we used, okay? And sometimes we also use the eta square, okay? N represents sample size, mean is the difference of paired samples. SD represents standard deviation of those difference. So now we know there are two variables in this data. One variable is pay, the other is security. So what is the questions here? We want to ask two questions. Question 1, mean differences. Are employees more concerned on the average about job security or salary level? Question 2, relationship between variables. Is degree of concern related to job characteristics of pay and security? Okay. So, to answer the first question, are employees more concerned on the average about job security or salary level? So we compare paired samples. Because why it is paired? Because each data coming from each employee, the first employee gave the pay rate 4, gave security rating 3. The second employee gave pay rating 9, gave security rating 1. So each paired data represent one employee. Okay. So now we are going to use the paired samples t-test. Go to analyze, compare means, paired samples t-test. We have two variables. So select pay, then select security. Click this go to button. After that, you click OK button. Okay. Now you get the result. So I'm going to maybe copy this result to OneNote so that I can make annotation. So this one is lesson 23. Okay, let's focus on two values. One, test statistic. The other one is p-value. So where is test statistics? It is here. On the paired sample test, t-test statistic, that is 2.829. And where is the p-value? P-value if it is one-sided, it is 0.004. If it is two-sided, 0.008. Anyway, those are the p-value. If you are given alpha 0.05, those p-value smaller than alpha. When p-value smaller than alpha, you reject H0. So what is H0? H0 said, remember this is a paired sample. We use mu d, the difference, okay? The population mean difference, mu d equal to 0. Alternative hypothesis, mu d not equal to 0. If you further ask me what are the mu d, because this is the question commonly asked 23. So you have pay, you have security. Can you calculate the difference between pay and security? Of course you can. Do the transform compute variable. So I'm going to use D, represent the difference. I use pay minus security. That is my D, difference. Then I click OK button. Now I created the differences. Okay. So the difference here just represent the sample. I want to say behind this sample, there are populations. I want to say if the population for those difference equal to 0 or not. That is my hypothesis. Okay, so this D, you have average, but behind those sample, you also have population. Okay, so just want to explain what is the mu D, the mean of the difference for population. Okay, if the mean for difference for population equal to 0, that means rating for pay is not different from security, or they are similar or the same. No significant difference between those two variables. That is our hypothesis for whole population. Okay, and our result based on p-value method, we reject H0 in favor of H1, means the mean difference for population is not equal to 0. The interpretation is the rating for pay is different from the rating for security. That is final conclusion. There are different readings. They're rating differently. Okay. So that is our p-value method. If you use critical value method, you compare critical value with test statistic. Okay, again, we have a sample size 30. Critical value is the same as here, 2.045. So this test statistic, 2.8, is in the rejection region. So you reject H0 based on critical value method. Critical value method, 2.045 is critical value, decide rejection region. And now your test statistic is in the rejection region, 2.827. So reject H0. Okay. Any questions for paired sample t-test? Paired sample t-test. And lastly, we can create a graph, create a box plot, okay, for both pay and security. Okay. So how do we create a box plot? You go to graph, legacy dialog, then box plot, and select simple, and also select summaries for groups or cases. Quick define, okay. And then the box represents pay, and also move security to, hold on, summaries. Actually separate cases. So I'm going to, so graph, legacy graph, then separate cases, separate variables, summaries of separate variables. The reason is we have two different variables, pay and security. Okay. So now box represent pay, also represent security. And then you click OK button. You have this box plot. The first box plot represents concern for pay. The second box plot represents concern for security. Based on this box plot, the mean value for concern for pay is here. I will copy this. So this is the output, graphic output. So the mean value for pay is here. The mean value for security is here. Those two mean values have a big difference. That is our result. Okay, those two values are different. The ratings for pay is different from the rating for security. Okay. All right, any questions? So this is a paired samples. Next lesson, lesson 24 is independent samples test. So we are going to open the data file for lesson 24. Lesson 24. And for this data, we have again 30 participants. Each participant asked, there are two variables. One is a stress variable, and the other is talk. Okay. And if you go to variable view, the stress variable have either 1 or 2. 1 represent low stress, 2 represent high stress. And for the talk is defined as percentage of time that each student talked during the 10-minute test period. Okay. So go back to the data. Stress level. We use the stress level, divide the data talk into two groups. One group of students, their stress level is low. Those are the talk. The time, okay, during the 10-minute test period, how much students talked. Okay, so this is for level students, low stress level. Those are the time recorded for low stress level students. Now, for high stress level students, those are the time recorded for high stress students. So we want to see if the average for low stress students equal to or not equal to the average for high level stress students. That is our question. That is what we want to test. Okay. So there are two independent variables because a person is either low stress or high stress. Assume just two types of students, low stressed, high stressed. We want to compare low stress students with high stress students in terms of the percentage of time that they talk during the 10 minutes test period. Any questions about the data itself? Right. So now we do analyze, compare means, independent samples t-test. Test variable is talk, and this variable is based on stress. And stress is based on group 1 or group 2. Group 1 is low stress students, value is 1. Group 2 is 2. So click continue, and then click OK button. And this is our result. I'm going to copy this result so that I can make a notation. All right, two methods. So first of all, let's define what is H0, what is H1. Null hypothesis said there are two groups of students. One group is low stress, the other group high stress. If the mean value for low stress student is mu1, the mean value for high stress student is 2. So null hypothesis said those two population means are equal. So the mean score for low level students is the same as the mean score for high level stress students. That is null hypothesis. Alternative hypothesis, those two means are different. Those are the null hypothesis, alternative hypothesis. So two methods to answer that question. Are there any difference between two population means? Method 1, use p-value. When you use p-value, you are given two lines here. One is equal variance are assumed. The other is equal variance are not assumed. Usually, people select the first one, equal variance assumed. Whose variance? Population variance. We assume two population variance are the same. If we assume two population variance are the same, we look at the p-value here, depending on it's one tail or two tail. In my case, because I said not equal, so I should select two-tailed test. If you have not equal, that is the indication of two-tailed test. So now, alpha always use 0.05 in this class, unless specified otherwise. Okay, now p-value 0.02, alpha 0.05. This p-value smaller than alpha. When p-value smaller than alpha, reject H0. Reject H0. See, what is H0? H0 says mu1 equal to mu2. You reject it. When you reject H0, you are in favor of H1. So you conclude the population mean for low stress level student is not the same as for high stress level students. Those two population means are not equal. Okay, that is your conclusion for p-value method. And for t-test statistic is here, 2.43, because sample size is sample size you have to use is depend. So for two independent samples, sample size, let me double check, the degree of freedom. Some people use N1 plus N2 minus 2. Some people choose the smaller of sample size -1. Okay, I'm double check on this. Normal 1, 2. So the degree of freedom for this one, we are going to use, this is N1, less stress student, we have 15. High stress student, we have 15. So the degree of freedom, by definition, we use smaller of N1 minus 1, N2 minus 1. So it is 14. We use 14 as degree of freedom. Okay, if you use 14 as degree of freedom, alpha is 0.05. So critical value equal t dot inv dot 2t. Alpha 0.05, degree of freedom 14. So you get 2.144. 2.144 is the critical value. Okay, so I'm going to write down somewhere here. So from Excel, t dot inv dot 2t, 0.05, 14. 14478. Okay, so this is critical value. Compare critical value with test statistic. You reject at 0. The same conclusion. Okay. So that is a 2 independent sample test. Are there any questions? Anything? That is unit 6. Unit 6. Questions? Let me check the message. Any questions? Okay. Shall we take a second break? After second break, we'll move on unit 7. Unit 7. Okay. So I'm going to stop recording. So shall we come back at 3:05? 5 minutes after 3. 5 minutes after 3. So I'm going to stop recording. When I come back, I will remember to start recording.